Hello, dear listener. Tonight, we'll follow the quiet threads of scientific thought, tracing them through time, space, and the strange beauty of the unknown. Whether you're cozied up indoors or listening with headphones under the stars, I'm grateful to have you here. Tell me in the comments, where are you tuning in from and what hour has found you? If calm, thoughtful explorations bring you peace, I'd love for you to subscribe. The universe is vast and we're just getting started. 400 years ago, when Galileo first turned his crude telescope toward Saturn in 1610, he saw something that puzzled him deeply. The planet appeared to have handles, or perhaps ears, protruding from its sides. His telescope wasn't powerful enough to reveal the truth, so he wrote in his notes, cryptically, that Saturn seemed to be triple-bodied. He was seeing the rings, of course, but couldn't quite make sense of what his eyes were telling him. It wasn't until 1659 that Dutch astronomer Christian Huygens, with a better telescope and keener insight, realized what those mysterious appendages truly were. A thin, flat ring surrounding the planet, nowhere touching it. He described it as a thin, flat ring, nowhere touching and inclined to the ecliptic. It was a revelation that transformed our understanding of what planets could be, what they could wear like cosmic jewelry as they wandered through the void. But even Huygens, brilliant as he was, saw only one ring. As telescopes improved through the centuries, that single band revealed itself to be far more complex. Giovanni Cassini discovered gaps in the rings in 1675, realizing they weren't solid disks, but collections of countless particles. The largest gap, still bearing his name today, seemed to divide the rings into distinct sections like the grooves on a cosmic record player. What Cassini and those early astronomers were witnessing was just the beginning of Saturn's story. Those rings, which appear so solid and permanent from our distant perspective, are actually made of billions upon billions of individual pieces of ice and rock, each following its own orbital path around the planet. Some chunks are as small as dust motes, others as large as houses, all of them caught in an intricate gravitational dance that's been playing out for eons. The rings extend outward from Saturn for hundreds of thousands of kilometers, yet they're remarkably thin. If you could shrink them down to the size of a compact disc, they would be thinner than a sheet of paper. This vast, delicate structure spinning in the darkness is one of the most beautiful and precisely organized systems in our solar system, a testament to the elegant mathematics of gravity and motion. From Earth, even with our most powerful telescopes, the rings appear as smooth, continuous bands divided by dark gaps. But when spacecraft began visiting Saturn, starting with Pioneer 11 in 1979, then Voyagers 1 and 2 in the early 1980s, and finally the magnificent Cassini mission that orbited Saturn for 13 years, we discovered that what seemed simple was breathtakingly complex. The rings aren't just a few broad bands, but thousands upon thousands of narrow ringlets, each with its own character, its own density, its own story. Some are braided together like cosmic hair. Others have spokes of darker material that rotate like the arms of a ghostly windmill. There are rings that seem to shepherd the particles of other rings, keeping them in line through gravitational influence. There are gaps that aren't empty at all, but filled with their own faint collections of debris. And within this system, we find some of Saturn's smaller moons acting as cosmic gardeners. These shepherd moons, as they're called, orbit near the rings and help maintain their structure. Prometheus and Pandora, two small moons, work together to keep the particles of the F-ring corralled, their gravitational influence preventing the ring from spreading out into space. It's as if they're cosmic sheepdogs, quietly maintaining order in the celestial flock. The composition of the rings tells us stories about their origin and age. They're made primarily of water ice, which gives them their brilliant reflectivity and creates the golden glow we see when sunlight illuminates them. Mixed in with the ice are traces of rocky material, organic compounds, and dust from countless micrometeorite impacts over millions of years. The ice isn't pure and pristine like fresh snow, but aged and weathered, carrying the subtle signatures of eons spent in the harsh environment of space. This raises one of the most intriguing questions about Saturn's rings. How old are they? For decades, scientists assumed they were as ancient as Saturn itself, formed during the chaotic early days of the solar system over 4 billion years ago. But recent observations from the Cassini spacecraft suggest a different story. The rings may be surprisingly young in cosmic terms, perhaps only 100 to 200 million years old. If this is true, then the rings we see today formed when dinosaurs were already roaming the Earth, making them relative newcomers to the solar system. How could something so magnificent be so young? The answer might lie in destruction as much as creation. The rings could be the remains of a moon that wandered too close to Saturn and was torn apart by tidal forces, its icy debris spreading out into the elegant bands we see today. Or perhaps they're the result of a collision between two of Saturn's moons, their shattered remains caught in the planet's gravitational embrace and slowly ground down into the countless particles that now dance in eternal orbit. The process isn't finished either. The rings are constantly evolving, particles colliding and sticking together, others being pulled apart by gravitational forces. Material from the rings rains down onto Saturn's atmosphere, creating a gentle but constant precipitation of ring particles. At the same time, Saturn's moons and the solar wind continue to supply new material, keeping the system in a delicate balance between creation and destruction. As you listen to this, somewhere above the clouds of Saturn, billions of ice particles are catching and reflecting sunlight, creating one of the most beautiful sights in our solar system. Each particle follows the same fundamental laws of physics that govern the motion of planets and stars, yet together they create something that appears almost magical, a structure so perfect it seems designed rather than evolved. The rings change with Saturn's seasons too. As the planet orbits the sun over its 29-year cycle, different faces of the rings are illuminated, creating shifting patterns of light and shadow. Sometimes we see them edge on when they nearly disappear from view, appearing as just a thin line across Saturn's face. Other times, they're fully open to our perspective, displaying their full glory like a cosmic flower in bloom. Within the ring system, each region has its own personality. The C ring, closest to the planet, is so transparent it's sometimes called the crepe ring, barely visible except when backlit by the sun. The B ring is the brightest and most opaque, so dense with particles that it blocks virtually all light trying to pass through it. The A ring, separated from the B ring by the famous Cassini division, contains some of the most complex structures, including the narrow F ring with its braided appearance and the faint outer rings that extend far into space. These outer regions of the ring system are home to some of Saturn's most mysterious features. The E ring, for instance, is supplied by geysers erupting from the moon Enceladus, creating a tenuous halo of ice crystals that extends far beyond the main ring system. It's a direct connection between the geological activity of a moon and the structure of the rings, showing how intimately connected all parts of the Saturnian system truly are. The G ring, discovered by Voyager, is maintained by impacts on small moons within the ring itself, each collision sending up clouds of debris that slowly settle back into the orbital dance. Even the outermost Phoebe ring, discovered only in 2009 by the Spitzer Space Telescope, tells a story of ancient impacts and the slow migration of dust across vast distances. What makes Saturn's rings even more remarkable is their temporary nature. Despite their appearance of eternal stability, they're gradually disappearing. The same processes that maintain them also slowly erode them away. Material spirals inward towards Saturn or is lost to space, and without constant replenishment, the rings will eventually fade away entirely. Current estimates suggest they might last another 100 million years or so, which sounds like a long time, but is merely a moment in the 4.6 billion year history of our solar system. This means we're living at a special time in cosmic history when Saturn wears its magnificent crown of rings. Creatures on Earth, a billion years from now, if they exist, may look up at Saturn and see only a bare planet, the rings having long since dissipated into space or fallen into the planet's atmosphere. We're witnessing something transient and precious, a cosmic light show that won't last forever. The beauty of Saturn's rings isn't just in their appearance, but in what they teach us about the fundamental forces that shape our universe. They're a natural laboratory for studying gravitational dynamics, showing us how particles interact over vast scales and long periods of time. The same processes that create and maintain Saturn's rings operate in the formation of planetary systems around other stars, in the accretion disks around black holes, and in the grand spiral arms of galaxies. Every time we look at Saturn through a telescope, whether it's a small backyard instrument or the mighty Hubble Space Telescope, we're seeing the results of billions of individual particles obeying the simple laws of physics. Yet from that simplicity emerges complexity and beauty that takes our breath away. It's a reminder that the universe doesn't just follow mathematical laws, it creates art while doing so. The study of Saturn's rings has also revealed the incredible precision with which celestial mechanics operates. The gaps in the rings aren't random, but occur at specific distances where the orbital periods of ring particles would create resonances with Saturn's moons. These gravitational resonances sweep particles away from certain orbits, creating the dark divisions we see. It's like a cosmic tuning fork, with Saturn's moons striking precise notes that resonate through the ring system, creating harmony from what might otherwise be chaos. Some of the most beautiful features in Saturn's rings are created by these resonances. The Encke gap, a narrow division in the A ring, is maintained by the small moon pan, which orbits within the gap itself, sweeping up particles and keeping the space clear. The moon creates wakes in the ring material as it passes, like a tiny boat moving through a sea of ice, leaving ripples that can be seen in high-resolution images from spacecraft. These shepherd moons don't just maintain gaps, they also create some of the ring's most intricate structures. The F ring, with its kinked and braided appearance, owes its complex shape to the gravitational influence of Prometheus and Pandora. As these moons orbit at slightly different speeds, they alternately stretch and compress the ring material, creating the twisted rope-like structures that have puzzled and delighted astronomers since their discovery. Perhaps most remarkably, the rings exhibit behavior that seems almost alive. The spokes in the B ring, dark radial features that appear and disappear with Saturn's rotation, were first discovered by Voyager and initially defied explanation. They form when tiny particles become electrically charged and levitate above the main ring plane, creating temporary structures that rotate with Saturn's magnetic field. It's electrostatic forces, not gravity, that creates these ghostly features, showing that even in the apparent simplicity of orbiting ice particles, complex physics is always at work. The colors of Saturn's rings, subtle but distinct, tell us about their composition and history. The C ring has a slightly blue tint, suggesting smaller particles that scatter blue light more effectively. The A and B rings appear more golden, their larger particles reflecting the warm light of the distant sun. Variations in color across the ring system reveal the complex history of impacts, collisions, and the slow evolution of the particles over millions of years. When the Cassini spacecraft ended its mission in 2017, diving into Saturn's atmosphere in a planned destruction to avoid contaminating any of Saturn's potentially habitable moons, it had revolutionized our understanding of the ring system. Its final observations made during its grand finale orbits between the planet and the rings, revealed that the rings are even more complex and dynamic than anyone had imagined. Cassini discovered that material from the rings is constantly raining down onto Saturn's atmosphere, creating a gentle but measurable influx of water and organic compounds. This ring rain, as it's called, affects the composition and temperature of Saturn's upper atmosphere, showing that the rings and the planet are intimately connected, each influencing the other in subtle but important ways. The spacecraft also revealed that the rings have their own weather systems. Temperatures vary across the ring system, affected by the density of particles, their distance from Saturn, and their exposure to sunlight. Some regions are warmer where particles absorb more sunlight, others cooler where Saturn's shadow provides relief from the sun's rays. These temperature variations affect how the particles behave, influencing everything from their tendency to stick together to their ability to maintain complex structures. As we've learned more about Saturn's rings, we've also discovered that they're not unique in our solar system, though they are by far the most spectacular. Jupiter has rings, discovered in 1979 by Voyager 1, though they're so faint they're virtually invisible from Earth. Uranus and Neptune also have ring systems, dark and narrow compared to Saturn's brilliant display. Each system tells its own story of formation and evolution, but none matches the grandeur and complexity of Saturn's cosmic crown. The existence of rings around other planets suggests that they might be common features of giant planets, perhaps forming whenever the right conditions of moons, impacts, and gravitational dynamics come together. As we discover more exoplanets around other stars, particularly giant planets in distant solar systems, we might find that ringed worlds are scattered throughout the galaxy, each one a unique expression of the fundamental forces that shape planetary systems. But for now, Saturn remains the jewel of our solar system, its rings a constant source of wonder and scientific discovery. Every image returned by spacecraft, every observation made by ground-based telescopes, reveals new details about this magnificent structure. We've learned that what appears simple from a distance is incredibly complex up close, that what seems permanent is actually dynamic and ever-changing, and that what looks like a solid structure is actually composed of countless individual particles, each following its own path through space. The rings of Saturn remind us that beauty in the universe often emerges from the interplay of simple forces over vast scales of time and space. Gravity, the weakest of the fundamental forces, has sculpted these delicate structures through patient, persistent action over millions of years. Each particle in the rings follows the same basic laws of orbital mechanics that govern the motion of planets and stars. Yet together, they create something that transcends the sum of its parts. As you drift towards sleep tonight, perhaps you can imagine floating high above Saturn, looking down at those magnificent rings spread out below like a vast, shimmering disk. Billions of ice particles catch and scatter the golden light of the distant sun, each one a tiny mirror reflecting the glory of our star across the darkness of space. The rings stretch away in all directions, so thin they seem like an illusion, yet so vast they dwarf entire continents on Earth. In the distance, Saturn's moons patrol their ancient orbits, some shepherding the ring particles with their gravitational influence, others contributing new material through volcanic eruptions or impacts from space debris. The entire system moves with clockwork precision, each component affecting all the others in an intricate dance that has been playing out for millions of years and will continue for millions more. The silence up there is absolute, broken only by the occasional impact of a dust grain or the gentle collision of ice particles. Yet in that silence, there's a kind of music, the mathematical harmony of orbital mechanics, the rhythm of resonances, and the melody of gravitational forces shaping matter into patterns of incredible beauty. It's Saturn's silent symphony, playing out on a scale too vast for human ears, but perfectly audible to the instruments of science and the imagination of those who love to explore the cosmos. From our small world, circling our ordinary star in an unremarkable corner of the galaxy, we can look up at Saturn and see one of the universe's greatest masterpieces. Those rings, visible in even a small telescope on a clear night, connect us to the cosmic forces that shaped our solar system and continue to sculpt it today. They remind us that we live in a universe of incredible beauty and complexity, where the simple laws of physics create wonders beyond our wildest dreams. So as you close your eyes tonight, carry with you the image of Saturn's rings, that silent symphony of ice and gravity playing out in the darkness between worlds. Let their serene beauty remind you that even in the vast emptiness of space, there is order, there is elegance, and there is a kind of cosmic music that speaks to something deep within us, something that recognizes beauty wherever it appears in this magnificent universe we call home. Thank you for joining me on this gentle journey to Saturn's rings. Sweet dreams, fellow traveler, and may your rest be as peaceful as the eternal dance of ice particles around the jewel of our solar system. Looking at the vastness of space, we often think of it as empty, a cosmic void punctuated by scattered points of light. But the universe holds a secret that transforms this perception entirely. Between the galaxies, woven through the darkness like an invisible symphony, lies a structure so magnificent and complex that it defies our earthbound imagination. Tonight, we drift into the realm of Saturn's rings, those delicate bands of ice and rock that have captivated astronomers for centuries, whispering their silent secrets across the solar system. From our vantage point on Earth, Saturn's rings appear as thin, elegant lines circling the giant planet like a cosmic record spinning in slow motion. But venture closer, and these seemingly simple bands reveal themselves to be intricate worlds unto themselves, each particle dancing in perfect gravitational harmony, each gap and division telling a story billions of years in the making. The rings are not solid structures as they might appear through a telescope, but rather collections of countless individual pieces, from tiny ice crystals no larger than snowflakes to house-sized boulders, all caught in Saturn's gravitational embrace. The story of how we came to understand these celestial ornaments begins in 1610 when Galileo Galilei first pointed his primitive telescope toward Saturn. What he saw puzzled him greatly. The planet appeared to have strange appendages, bulges on either side that he described as handles or ears. His telescope was not powerful enough to resolve the true nature of what he was seeing, and he wrote in frustration that Saturn seemed to devour its own children, as the rings would appear and disappear depending on their orientation relative to Earth. It wasn't until 45 years later that Dutch astronomer Christian Huygens, with a more advanced telescope, finally solved the mystery. Saturn, he declared, was surrounded by a thin, flat ring that never touched the planet. As telescopes improved over the centuries, so did our understanding of Saturn's rings. What Huygens saw as a single ring was revealed to be multiple rings separated by gaps. The astronomer Giovanni Cassini discovered the most prominent of these gaps in 1675, a division so significant it now bears his name. The Cassini division, as it came to be known, is a 4,800-kilometer wide gap that separates the bright B ring from the fainter A ring. Through Earth-based observations, astronomers identified more rings and more divisions, each discovery adding another layer of complexity to Saturn's ethereal crown. But it wasn't until the space age that we truly began to comprehend the remarkable intricacy of Saturn's ring system. The Pioneer 11 spacecraft provided our first close-up glimpse in 1979, followed by the two Voyager missions in 1980 and 1981. These robotic explorers revealed that Saturn's rings were far more complex than anyone had imagined. What appeared from Earth as solid bands were actually composed of thousands of individual ringlets, some braided together, others showing strange spoke-like features that seemed to rotate with the rings themselves. The Cassini spacecraft, which arrived at Saturn in 2004 and spent 13 years studying the system, revolutionized our understanding once again. Named after the astronomer who discovered the Great Division, Cassini revealed the rings in unprecedented detail. It showed us shepherd moons, tiny satellites that help maintain the ring's structure by gravitationally sculpting their edges. It discovered propeller-shaped gaps created by moonlets embedded within the rings themselves. It observed the rings' seasonal changes and documented their incredible thinness relative to their vast diameter, some sections being only about 10 meters thick while spanning hundreds of thousands of kilometers across. The composition of Saturn's rings tells a story of cosmic recycling and renewal. They are made primarily of water ice ranging from 95 to 99% pure, with traces of rocky material mixed in. This ice gives the rings their brilliant reflectivity, making them easily visible from Earth despite their great distance. The particles range dramatically in size, from microscopic dust grains to chunks the size of houses, all orbiting Saturn at different speeds depending on their distance from the planet. Each ring has its own character and personality. The D ring, closest to Saturn, is thin and faint, composed mostly of fine dust particles. The C ring, sometimes called the crepe ring due to its gauzy appearance, contains darker material mixed with the ice. The B ring is the most massive and opaque, so dense that it blocks nearly all light trying to pass through it. The A ring, separated from the B ring by the Cassini division, contains the famous inky gap, a narrow division maintained by the small moon Pan. Beyond the A ring lies the faint F ring, a narrow band kept in place by two shepherd moons, Prometheus and Pandora, which create its characteristic braided appearance through their gravitational influence. The origin of Saturn's rings remains one of the most intriguing mysteries in planetary science. There are several competing theories, each with its own compelling evidence. One possibility is that the rings are the remains of an ancient moon that wandered too close to Saturn and was torn apart by tidal forces. When an object approaches within what's called the Roche limit, the gravitational gradient becomes so steep that the object is literally pulled apart, with pieces closer to the planet feeling a much stronger gravitational pull than those farther away. Another theory suggests that the rings formed from the debris of a collision between two of Saturn's moons, a cosmic car crash that scattered ice and rock into orbit around the planet. Still others propose that the rings are made from material that never had the chance to coalesce into a moon in the first place, primordial debris left over from Saturn's formation 4.6 billion years ago. Recent evidence from Cassini has provided intriguing clues about the ring's age. By measuring how much interplanetary dust has accumulated on the ring particles, scientists have estimated that the rings may be surprisingly young in cosmic terms, perhaps only 100 to 200 million years old. This would make them younger than the dinosaurs, cosmic newcomers in a solar system that has existed for over 4.5 billion years. The ring's youth suggests they may be the result of a relatively recent catastrophic event, perhaps the destruction of a moon that survived for billions of years before meeting its dramatic end. The dynamics of the ring system are governed by a delicate interplay of gravitational forces. Saturn's moons, particularly the larger ones, exert gravitational influences that create resonances within the rings. These resonances are locations where ring particles complete a certain number of orbits in the same time it takes a moon to complete a different number of orbits, creating a mathematical harmony that either clears out gaps or enhances ring material. The Cassini division, for example, is maintained by a 2-to-1 resonance with the moon Mimas. Ring particles in this region complete 2 orbits for every 1 orbit of Mimas, and this resonance prevents particles from maintaining stable orbits there. Some of the most beautiful features in Saturn's rings are created by embedded moonlets, small objects just a few kilometers across that orbit within the ring material itself. These moonlets create what are called propeller features, gaps that look like airplane propellers from above. The moonlets are too small to be seen directly, but their gravitational influence on surrounding ring particles creates these distinctive patterns that can stretch for hundreds of kilometers. The spokes in Saturn's rings, first observed by Voyager and studied extensively by Cassini, represent another fascinating phenomenon. These are temporary features that appear as radial streaks across the rings, rotating with Saturn's magnetic field rather than following the orbital motion of the ring particles. They are thought to be caused by electromagnetic forces acting on tiny dust particles, lifting them slightly above or below the main ring plane, where they become visible as they scatter sunlight differently than the surrounding material. The rings also exhibit seasonal behavior, changing their appearance as Saturn orbits the Sun. Every 15 years or so, Earth passes through the plane of Saturn's rings, causing them to appear edge-on and nearly invisible due to their extreme thinness. During these ring plane crossings, astronomers can observe features that are normally hidden by the ring's brightness, such as small moons orbiting close to the planet. The temperature of the ring particles varies depending on their location and exposure to sunlight. In Saturn's shadow, temperatures can drop to around minus 180 degrees Celsius, while in direct sunlight, they may warm to minus 110 degrees Celsius. This temperature variation affects the physical properties of the ice particles and may contribute to some of the dynamic behaviors observed in the rings. Saturn's rings are not static structures, but are constantly evolving. Ring particles collide with each other, merge, and break apart in an endless cycle of destruction and renewal. Meteoroids from elsewhere in the solar system occasionally strike the rings, adding new material or creating temporary disturbances. The rings are also slowly spiraling inward towards Saturn, raining down on the planet's upper atmosphere at a rate of several tons per second. This ring rain was detected by Cassini and suggests that the rings are gradually disappearing, destined to vanish completely in perhaps 100 to 300 million years. The different rings also interact with Saturn's magnetosphere, the region of space dominated by the planet's magnetic field. Charged particles trapped in the magnetosphere can sputter ice from ring particles, creating a tenuous atmosphere of water vapor around the rings. This interaction also creates auroras in Saturn's atmosphere, beautiful light displays similar to Earth's northern and southern lights, but powered by ring material rather than solar wind. One of the most remarkable aspects of Saturn's rings is their incredible thinness relative to their diameter. If you were to make a scale model of the rings using a piece of paper to represent their thickness, the diameter would need to be about the length of a football field. This extreme flatness is a result of the ring's formation and evolution, as collisions between particles naturally flatten the system into a thin disk aligned with Saturn's equatorial plane. The shepherd moons that help maintain the ring's structure represent a beautiful example of gravitational choreography. These small moons, often only tens of kilometers across, orbit just inside or outside ring boundaries. Their gravity creates waves in the ring material, compressing some regions and rarefying others, ultimately keeping the rings confined to specific regions. Without these shepherd moons, the rings would gradually spread out and dissipate over time. The colors visible in Saturn's rings, while subtle, provide clues about their composition and history. The C ring appears slightly redder than the others, suggesting it contains more rocky material. The B ring shows variations in color that may indicate different particle sizes or compositions in different regions. These color differences are thought to result from the bombardment of ring particles by charged particles in Saturn's magnetosphere, which can chemically alter the surface properties of the ice. As Cassini's mission drew to a close in 2017, it provided us with one final gift, a series of orbits that took it between Saturn and its rings, closer to the planet than any spacecraft had ever ventured. These grand finale orbits revealed new details about the ring's mass, age, and internal structure. The data collected during this phase will keep scientists busy for years to come, continuing to refine our understanding of these magnificent structures. The study of Saturn's rings has implications far beyond our solar system. Ring systems have been discovered around all 4 giant planets in our solar system, and even around some asteroids. Understanding how these systems form and evolve helps us comprehend the processes that shaped our solar system and others. The physics governing ring dynamics also applies to protoplanetary disks, the structures around young stars where planets form, making Saturn's rings a natural laboratory for studying planet formation processes. Looking toward the future, several missions are being considered to continue the study of Saturn and its rings. The challenges are immense, given the vast distance to Saturn and the complexity of the system, but the scientific rewards would be equally substantial. Future missions might include orbiters with even more advanced instruments, atmospheric probes to study the ring rain phenomenon, or even sample return missions to bring ring material back to Earth for detailed laboratory analysis. The aesthetic beauty of Saturn's rings has inspired artists, poets, and dreamers for centuries. They represent one of nature's most perfect examples of order emerging from chaos, billions of individual particles working together to create structures of breathtaking elegance. In many ways, they serve as a metaphor for the broader cosmos itself, where simple physical laws give rise to complexity and beauty on scales both vast and minute. As we continue to study Saturn's rings, we are reminded of the dynamic nature of our solar system. These structures that appear so permanent and serene from Earth are actually in constant motion, constantly changing, constantly evolving. They connect us to the larger story of cosmic evolution, from the formation of the solar system to its ultimate fate, billions of years in the future. The silence of Saturn's rings is perhaps their most poetic quality. In the vacuum of space, these countless particles orbit in perfect quiet, their gravitational dance unheard except by the sensitive instruments of our spacecraft. Yet in their silence, they speak volumes about the forces that shape our universe, the delicate balance between order and chaos, and the extraordinary beauty that emerges when simple physical laws operate over cosmic scales of space and time. Looking at the vast expanse of space, we find ourselves gazing into a cosmic symphony that's been playing for over 13 billion years. Saturn's rings may seem like silent sentinels from our earthbound perspective, but they tell a story of constant motion, delicate balance, and extraordinary beauty that rivals any earthly orchestra. As we continue our journey through Saturn's magnificent ring system, we encounter phenomena that challenge our understanding of how such intricate structures maintain their harmony. The rings are not the static, solid disks they appear to be from afar, but rather dynamic collections of countless particles engaged in an eternal dance around their giant host. Within the main ring divisions, we discover a universe of subtle variations. The Cassini division, that prominent gap between the A and B rings, isn't actually empty space, but contains its own collection of ring material, including the narrow Huygens ringlet. This gap exists because of gravitational resonances with Saturn's moon Mimas, whose orbital period creates a zone where ring particles cannot maintain stable orbits. It's as if Mimas acts as a cosmic conductor, clearing certain sections of the orchestra pit while allowing others to flourish. The B ring, the brightest and most massive of Saturn's rings, contains mysteries that continue to perplex astronomers. Its opacity varies dramatically across its width, creating a complex pattern of light and shadow that changes as Saturn orbits the Sun. During Saturn's equinox, when sunlight strikes the ring's edge on, we can observe the true three-dimensional structure of these seemingly flat formations. Towering spires of ring material, some reaching heights of several kilometers, cast shadows across the ring plane, like mountains on a cosmic landscape. Perhaps most intriguing are the propeller features discovered by the Cassini spacecraft during its 13-year mission around Saturn. These small, elongated gaps in the rings are created by moonlets roughly the size of football fields, too small to be directly observed, but large enough to carve distinctive patterns in the surrounding ring material. Like tiny shepherds tending their flocks, these embedded moonlets create wakes and gaps that persist as they orbit Saturn, leaving behind propeller-shaped clearings that can be tracked over time. The F-ring presents its own set of mysteries. This narrow, kinked ring lies just outside the main ring system and displays a remarkable tendency toward chaos. Braided sections appear and disappear, bright knots of material form and dissolve, and the entire ring seems to writhe like a cosmic serpent. Two small moons, Prometheus and Pandora, act as shepherds for this unruly ring, but their gravitational influence creates as much chaos as order, pulling streamers of material away from the ring core and then allowing them to fall back in unpredictable patterns. The seasonal nature of Saturn's rings adds another layer of complexity to their story. As Saturn's 29-year orbit carries it around the Sun, the angle at which sunlight strikes the rings changes dramatically. During the planet's northern summer, the ring's northern face is illuminated, while during southern summer, we see the rings from below. These seasonal changes affect not only how we observe the rings, but also their physical properties, as the varying solar heating influences the behavior of the ring particles themselves. Temperature variations across the rings create convection currents and particle migrations that are only beginning to be understood. The ring particles absorb sunlight during Saturn's long seasons and radiate that energy back into space, but the process is far from uniform. Denser regions of the rings heat up differently than sparse areas, creating thermal gradients that drive subtle but persistent movements within the ring system. The discovery of water ice geysers erupting from Saturn's moon Enceladus has revealed another connection between the rings and the planet's moons. The material ejected from Enceladus creates a tenuous ring of its own, the E-ring, which extends far beyond the main ring system. This demonstrates that Saturn's rings are not isolated structures, but part of a larger, interconnected system that includes the planet's many moons and their complex gravitational relationships. Recent observations have also revealed the presence of organic compounds within the ring system, carried there by meteoritic bombardment and the constant rain of material from Saturn's upper atmosphere. These discoveries suggest that the rings are not pristine, unchanging structures, but dynamic environments where chemistry and physics interact in ways we're only beginning to understand. The gravitational influence of Saturn's many moons creates resonances throughout the ring system, zones where the orbital periods of ring particles match simple ratios with the periods of the moons. These resonances can either clear material away, creating gaps, or concentrate it, forming dense ringlets. The interplay between these various resonances creates a complex pattern of structure that extends throughout the entire ring system, from the innermost D-ring to the outermost gossamer rings that stretch nearly to the orbit of the moon Titan. As we peer deeper into the ring system's architecture, we find evidence of collisional processes that continuously reshape the rings. Ring particles collide gently and frequently, sharing momentum and energy in ways that tend to flatten the system and spread material outward. But occasionally, more energetic collisions occur, perhaps triggered by meteoroid impacts or gravitational perturbations, creating temporary disturbances that propagate through the rings like ripples on a pond. The electromagnetic environment around Saturn also plays a crucial role in ring dynamics. The planet's powerful magnetic field interacts with charged particles in the ring system, creating forces that can levitate tiny dust grains above the ring plane. This interaction between electromagnetism and gravity creates a complex, three-dimensional structure that extends well beyond the visible ring boundaries, encompassing clouds of microscopic particles that follow the magnetic field lines around the planet. Through all these discoveries, we begin to understand that Saturn's rings are not merely beautiful ornaments adorning a distant planet, but rather a natural laboratory where fundamental processes of physics and astronomy play out on a grand scale. They represent a preserved example of the disk-like structures from which planets and moons form, offering insights into the early history of our solar system and the processes that shape the worlds we see today. The ring's transient nature, slowly spiraling inward towards Saturn's atmosphere, reminds us that even the most majestic cosmic structures are temporary. In perhaps 100 million years, these magnificent rings will have faded away, leaving only memories and the scientific knowledge we've gathered during our brief overlap with their existence. This impermanence makes them all the more precious, a fleeting masterpiece in the cosmic gallery that we are privileged to witness and study during our own brief moment in the universe's long story. Now let's venture deeper into Saturn's magnificent symphony. We've marveled at the delicate architecture of the rings, traced their formation through cosmic collisions and gravitational sculpting, and witnessed their slow dance with time itself. But there's another layer to this story, one that reveals Saturn's rings not just as beautiful ornaments adorning a distant world, but as active, living laboratories where the fundamental forces of nature play out their eternal choreography. Picture, if you will, the view from a spacecraft drifting through the ring plane. You're surrounded by billions upon billions of particles, each one a tiny world unto itself. Some are no larger than grains of sand, others the size of houses, and a few rare giants stretch as wide as city blocks. They tumble and spin in the eternal twilight, catching Saturn's pale light and casting it back in gentle sparkles that stretch to infinity. But this isn't a static sculpture frozen in space. These particles are constantly in motion, constantly interacting, constantly changing. They collide with one another in slow-motion ballets, sometimes sticking together to form larger clumps, sometimes shattering into smaller fragments. It's a cosmic recycling program that has been running for millions of years, where matter is endlessly broken down and rebuilt, shaped and reshaped by forces both gentle and profound. The rings breathe with Saturn's magnetic field, an invisible hand that reaches out from the planet's core and touches every charged particle in the system. When solar wind streams past Saturn, it creates ripples and waves in this magnetic embrace, and the rings respond like wheat swaying in a celestial breeze. Electrons dance along magnetic field lines, creating auroras that shimmer not just in Saturn's atmosphere, but sometimes in the rings themselves, ghostly lights that flicker between the particles like cosmic fireflies. Temperature plays its own quiet role in this symphony. The rings are cold, brutally cold, with temperatures hovering around minus 180 degrees Celsius. At these frigid temperatures, water ice behaves almost like rock, hard and brittle and unforgiving. But even in this frozen realm, there are subtle temperature variations. Particles closer to Saturn feel more of the planet's gentle warmth, while those in the outer reaches experience the full bite of deep space. These temperature gradients create their own dynamics, influencing how particles move and interact, adding another layer of complexity to the ring system's behavior. And then there are the colors, subtle but unmistakable to those who know how to look. While Saturn's rings appear predominantly white or pale gold to our eyes, they contain a rainbow of hues visible in different wavelengths of light. Some regions appear reddish, perhaps stained by organic compounds or metallic dust. Others show hints of blue or green, signatures of different ice compositions or particle sizes. These color variations tell stories of the ring's history, mapping out regions where different processes have dominated, where different materials have accumulated, where the rings have been touched by different influences over their long existence. The shepherd moons continue their patient work, but they're not the only sculptors in this cosmic atelier. Saturn itself plays a role, its gravity creating tidal forces that stretch and squeeze the ring material in subtle but important ways. The planet's magnetic field channels charge particles and creates regions of enhanced or diminished activity. Even Saturn's atmosphere contributes as its uppermost layers interact with the innermost ring particles, creating a tenuous connection between the planet and its ornamental companions. Weather, in a sense, exists within the rings themselves. Density waves propagate outward from gravitational resonances, like ripples on a pond, creating regions of compression and rarefaction that move through the ring material at predictable speeds. These waves can interact with one another, creating interference patterns and standing waves that persist for years or decades. Sometimes they collide and cancel each other out, creating temporary gaps or cleared regions. Other times, they reinforce each other, creating enhanced density regions that shine more brightly in Saturn's reflected light. The rings also experience something akin to seasons, though not in the way we understand them on Earth. As Saturn orbits the Sun over the course of its 29-year journey, the angle at which sunlight strikes the rings changes gradually. Sometimes the Sun shines directly on the ring plane, illuminating both sides equally. Other times it approaches from steep angles, creating dramatic shadows and highlighting the ring's three-dimensional structure. These changing illumination conditions reveal different aspects of the ring system, like slowly rotating a sculpture under a spotlight to appreciate all its angles and contours. Electromagnetic phenomena add their own notes to the symphony. Radio waves generated by particle interactions create a kind of cosmic static that varies with the ring's density and composition. Plasma physics governs the behavior of charged particles, creating complex feedback loops between the rings, Saturn's magnetosphere, and the solar wind. These invisible processes influence everything from particle trajectories to the formation of spokes and other temporary features that appear and disappear like ghosts in the ring system. The relationship between Saturn's rings and its many moons extends far beyond simple gravitational shepherding. Some moons actually orbit within the ring system itself, tiny worldlets embedded in the particle streams, like islands in a flowing river. Others exchange material with the rings, either capturing ring particles that stray too close or contributing their own material through impacts or sublimation. This constant exchange means that the boundary between rings and moons is not always clear-cut. In some sense, they form a single integrated system where solid bodies and particle streams exist in complex, ever-changing relationships. Time itself flows differently in different parts of the ring system. Particles in the inner regions complete their orbits in just a few hours, experiencing hundreds of Saturn rises and Saturn sets in a single Earth day. Those in the outer reaches take much longer, their leisurely orbits lasting Earth days or even weeks. This creates a kind of temporal gradient across the rings where different regions experience time at different rates, like a cosmic clock with multiple hands moving at different speeds. And through it all, the rings continue their slow evolution. They're not the same today as they were yesterday, and they won't be the same tomorrow as they are today. Particles are constantly being lost to Saturn's atmosphere through ring rain, while others are gained from meteoroid impacts and moon interactions. The overall mass of the ring system fluctuates, possibly cycling through periods of growth and decline over geological timescales. The rings we see today are just one moment in a much longer story, a snapshot of a dynamic system caught in the middle of its ongoing transformation. This is the true nature of Saturn's rings. Not static decorations, but living, breathing, evolving structures that embody some of the most fundamental processes in the universe. They are laboratories where we can study gravitational dynamics, electromagnetic interactions, and the complex dance between order and chaos that governs so much of cosmic evolution. Every particle in the rings carries with it the history of the solar system and every interaction between particles writes another line in the ongoing story of how matter organizes itself in the vast reaches of space. As we continue to study these remarkable structures, we're not just learning about Saturn or about rings in general. We're gaining insights into the fundamental nature of how cosmic systems form, evolve, and maintain themselves over time. The rings are teachers, patiently demonstrating principles that apply not just to planetary systems, but to galaxies, star formation regions, and the large-scale structure of the universe itself. In their quiet, elegant dance around Saturn, they whisper secrets about the deep workings of nature, secrets that we're only just beginning to understand. As we continue our celestial journey through Saturn's frozen realm, we find ourselves drawn deeper into one of the solar system's most enchanting mysteries. The rings we've explored, those delicate ribbons of ice and rock, are far more than mere decorative bands encircling a distant world. They are active, breathing structures, constantly reshaping themselves through processes both violent and graceful, ancient and surprisingly recent. Picture, if you will, the rings as a vast cosmic construction site, one that has been active for millions of years. Here in the space between Saturn's cloud tops and its outer moons, countless particles dance in an intricate choreography orchestrated by gravity itself. Some collisions are gentle, like snowflakes brushing against one another in a winter breeze. Others are catastrophic, shattering house-sized boulders into glittering dust that catches and reflects the pale light of the distant sun. This is where our story takes a fascinating turn, because the rings are not the eternal, unchanging structures they might appear to be from Earth's perspective. They are young, cosmically speaking, perhaps only 100 to 200 million years old. To put this in perspective, when Saturn's rings first formed, complex life on Earth was just beginning to experiment with backbones and shells. The mighty dinosaurs were still tens of millions of years in the future, and humans wouldn't appear for another 200 million years. How do we know the rings are so young? The answer lies in their remarkable purity. Saturn's rings are almost blindingly white when seen in sunlight, composed of nearly pure water ice with only trace amounts of rocky material. This pristine composition tells us a story of recent birth because space is not a clean place. Over billions of years, the solar system has been filled with dust from comets, debris from asteroids, and the general detritus of cosmic evolution. Ancient ring systems would have accumulated this material like snow-gathering soot in a city, gradually darkening and becoming contaminated. Yet Saturn's rings remain startlingly clean, suggesting they formed relatively recently from a source that was itself pure ice. This source was likely a moon, perhaps one similar to Saturn's current ice-covered satellites like Enceladus or Mimas. Through some cosmic catastrophe, either a collision with a large asteroid or comet, or perhaps tidal forces that literally pulled the moon apart as it wandered too close to Saturn, this ancient moon was destroyed, its frozen remains scattered into the elegant bands we see today. The violence of this birth stands in stark contrast to the serene beauty of the rings today. Imagine the chaos of that primordial destruction as a world perhaps hundreds of kilometers across was torn apart, its icy mountains and frozen plains shattered into billions of fragments. The larger pieces would have collided and shattered further, while the smaller ones began the long process of settling into the flat, organized structure we observe today. But the ring's youth presents us with another mystery, one that speaks to the dynamic and ever-changing nature of our solar system. If Saturn has existed for over 4 billion years, why do we happen to live at the precise cosmic moment when it has rings? This is known as the timing problem, and it suggests that ring formation around Saturn might not be a one-time event, but rather a recurring cycle that has played out multiple times throughout the planet's history. Perhaps every few 100 million years, Saturn captures or destroys a moon, creating a new ring system that slowly evolves and eventually dissipates, only to be replaced by another. We might be witnessing just the latest act in a drama that has been playing out for eons, with Saturn alternately adorned and bare as moons come and go in the gravitational theater of the outer solar system. This cyclical nature of ring formation is supported by computer simulations that show how ring systems evolve over time. The same processes that maintain the rings today, their interactions with moons, and the slow inward spiral of material also ensure their eventual destruction. It's a cosmic example of the Buddhist concept of impermanence, everything arising, existing for a time, and then passing away, only to arise again in a new form. The rings we see today are also shaped by ongoing processes that continue to sculpt and refine their structure. The most dramatic of these is what scientists call ring rain, a phenomenon where charged particles from the rings spiral down into Saturn's atmosphere, creating luminous auroras as they burn up in the planet's upper atmosphere. This process, discovered by the Cassini spacecraft, is steadily eroding the rings, carrying away an estimated 10,000 kilograms of ring material every second. At this rate, the rings will be significantly diminished within a few 100 million years and gone entirely within a billion years. It's a sobering reminder that even the most magnificent cosmic structures are temporary, subject to the same forces of change and decay that govern everything in the universe, from the smallest atom to the largest galaxy. Yet even as the rings lose material to ring rain, they are simultaneously being reshaped by other forces. Impacts from meteoroids, tiny specks of cosmic dust, no larger than grains of sand, strike ring particles at tremendous speeds, sometimes shattering them into smaller pieces, other times welding them together through the heat of collision. These impacts also inject fresh material into the rings as the meteoroids themselves become part of the ring system. The electromagnetic environment around Saturn also plays a crucial role in ring dynamics. Saturn's powerful magnetic field traps charged particles, creating radiation belts similar to Earth's Van Allen belts but far more intense. These charged particles interact with ring material in complex ways, sometimes causing particles to become electrically charged and repel each other, other times creating conditions that allow particles to stick together more readily. Seasonal changes add another layer of complexity to ring behavior. Saturn's axis is tilted much like Earth's, creating seasons that last about 7 Earth years each. As Saturn orbits the Sun, different parts of the rings receive varying amounts of sunlight, causing them to heat up and cool down in cycles. This thermal cycling affects how ring particles move and interact, sometimes causing the rings to appear brighter or dimmer, and occasionally revealing structures that are invisible at other times. These seasonal variations were beautifully documented by Cassini during its 13-year mission, as the spacecraft watched the rings change their appearance with Saturn's long seasons. Sometimes the rings would seem to disappear entirely when viewed edge-on from Earth, so thin that they became invisible in our telescopes. Other times they would blaze with reflected sunlight, revealing intricate details in their structure that had never been seen before. The discovery of these dynamic processes has revolutionized our understanding of planetary rings in general. We now know that all ring systems, whether around Saturn, Jupiter, Uranus, or Neptune, are active, evolving structures shaped by a complex interplay of gravitational, electromagnetic, and collisional forces. They are natural laboratories where we can study fundamental physics in action, from the behavior of granular materials in microgravity to the effects of electromagnetic fields on charged particles. Perhaps most remarkably, studying Saturn's rings has given us insights into how planetary systems form and evolve. The same processes that shape ring particles, collisions, gravitational interactions, and electromagnetic forces also played crucial roles in the formation of planets themselves. In a sense, Saturn's rings are a living fossil of the early solar system, showing us in real time how gravity and physics can organize matter into ever more complex structures. As we drift deeper into contemplation of these cosmic processes, it's worth remembering that the story of Saturn's rings is ultimately our story too. The same physical laws that govern the dance of ice particles around Saturn also shaped the formation of our own planet and continue to influence its evolution. We are all part of the same cosmic symphony, notes in a vast composition that has been playing for billions of years and will continue long after we are gone. The rings remind us that beauty and impermanence are intimately connected, that the most magnificent structures in the universe are often the most fleeting. They teach us to appreciate the present moment because even cosmic timescales are temporary when viewed from the perspective of eternity. And they inspire us to look more closely at the world around us, to see the hidden dynamics and processes that shape everything from the smallest raindrop to the largest galaxy. In this quiet moment, as we contemplate the slow dance of ice and gravity around Saturn, we are reminded that we live in a universe of constant change and endless wonder, where even the most familiar sights hide mysteries waiting to be discovered, and where the boundary between the scientific and the sublime dissolves in the face of cosmic beauty. Our cosmic theater deepens as we venture into Saturn's ring plane, where billions of icy fragments perform their ancient dance in formations so precise they seem choreographed by the universe itself. These are not the simple rings Galileo glimpsed through his primitive telescope, mistaking them for handles on a cosmic teacup. No, these are complex breathing structures that pulse with electromagnetic energy and respond to forces both seen and unseen. Within the ring system lies a hidden world of shepherding moons, tiny sentinels that patrol the ring edges like cosmic border guards. Pan, barely 20 kilometers across, carves its way through the inky gap, creating ripples and waves that spread outward like the wake of a celestial boat. Its gravitational influence sculpts ring particles into elegant streamlines, demonstrating how even the smallest bodies can impose order on chaos through nothing more than persistent, patient gravity. The rings themselves are surprisingly thin, barely a kilometer thick in most places, despite spanning hundreds of thousands of kilometers across. Imagine a sheet of paper scaled up to the width of a football field, and you begin to appreciate their delicate geometry. Yet within this gossamer structure lies incredible complexity. The Cassini spacecraft revealed features called propellers, small disturbances in the ring material created by unseen moonlets no larger than city blocks. These invisible sculptors push ring particles aside, creating gaps and ridges that persist for years, like footprints in cosmic snow. Temperature plays a curious role in this frozen landscape. Ring particles range from house-sized boulders to grains of sand, all composed primarily of water ice with traces of rocky debris. During Saturn's long winter, temperatures plummet to minus 200 degrees Celsius, cold enough to make the ice harder than granite. Yet even in this frigid environment, the rings display dynamic behavior. Particles collide, stick together, break apart, and redistribute themselves in an endless cycle of construction and destruction. Electromagnetic forces add another layer of complexity to ring dynamics. Saturn's powerful magnetic field threads through the ring plane, creating electric charges on ice particles through various processes. These charged particles then interact with Saturn's magnetosphere, sometimes causing them to levitate slightly above the ring plane or creating spoke-like features that rotate with the planet's magnetic field rather than following orbital mechanics. These spokes appear and disappear with Saturn's seasons, suggesting a connection to the planet's changing relationship with the Sun. The most intriguing aspect of ring behavior may be their resonances with Saturn's moons. These gravitational relationships create some of the most precise structures in the solar system. The Cassini division, that dark gap between the A and B rings, exists because particles there would orbit Saturn exactly twice for every orbit of the moon Mimas. This 2-to-1 resonance creates a gravitational tug-of-war that prevents particles from maintaining stable orbits in that region. Over millions of years, these subtle but persistent forces have cleared the gap with clockwork precision. Similar resonances sculpt ring edges, create narrow gaps, and maintain the sharp boundaries between different ring regions. The outer edge of the A ring is maintained by a 7-to-6 resonance with the small moon Janus, while the inner edge of the Cassini division corresponds to a 3-to-1 resonance with Mimas. These mathematical relationships, first predicted by celestial mechanics, demonstrate how the language of physics writes itself across the cosmos in structures of breathtaking beauty and precision. Perhaps most remarkably, the rings exhibit what scientists call viscous spreading, a process where gravitational interactions between particles cause the rings to slowly evolve over time. The inner regions tend to spiral inward towards Saturn, while the outer regions spread outward, like honey slowly flowing across a table. This process operates on timescales of millions of years, yet it's constantly reshaping the ring system's architecture. Recent observations have revealed that Saturn's rings are raining material onto the planet's upper atmosphere. This ring rain occurs when electromagnetic forces lift charged ice particles out of the ring plane, where they follow magnetic field lines down into Saturn's atmosphere. The rate of this precipitation suggests the rings are gradually disappearing, consumed by the very planet they orbit. Current estimates indicate the rings may vanish entirely within 100 million years, making them a relatively recent and temporary feature of the Saturn system. This transient nature adds poignancy to the rings' beauty. They likely formed from the destruction of an ancient moon, perhaps shattered by a comet impact or torn apart by tidal forces when it wandered too close to Saturn. The debris from this catastrophe spread into a disk around the planet, eventually organizing itself into the intricate structure we observe today. In cosmic terms, Saturn's rings are young, perhaps only a few 100 million years old, making them contemporary with complex life on Earth. The discovery of organic compounds within ring particles adds another dimension to their story. These carbon-based molecules, delivered by comets and meteoroids over millions of years, paint the rings in subtle hues of brown and red. The pure ice that dominates the ring's composition is gradually being contaminated by this cosmic dust, darkening the system over time. This process provides a natural clock, helping scientists estimate the ring's age and evolution. Ring particles also serve as tiny seismometers, recording the vibrations that travel through Saturn's interior. When the planet's core oscillates, these vibrations propagate outward and create detectable patterns in ring density. By studying these density waves, scientists have been able to peer inside Saturn itself, measuring the planet's rotation rate, internal structure, and even the size of its rocky core. The rings have become a natural laboratory for planetary science, revealing secrets about their parent planet that would be impossible to discover through any other means. The interplay between rings and moons creates some of the most dynamic features in the Saturn system. Small moons embedded within the rings, called moonlets, continuously sculpt their surroundings through gravitational interactions. These bodies are too small to clear complete gaps like larger moons, but they create wakes and disturbances that spiral outward in elegant patterns. The moon Daphnis, orbiting within the Keeler Gap, creates scalloped edges that rise and fall like waves as the moon's slightly inclined orbit carries it above and below the ring plane. Even Saturn's largest moon, Titan, influences the rings despite being hundreds of thousands of kilometers away. Its gravitational pull contributes to long-term orbital evolution and may play a role in maintaining certain ring structures. The complex gravitational dance between Saturn, its rings, and its retinue of moons creates a system where every component influences every other component, resulting in behaviors that emerge from the collective interactions of the whole. As we drift deeper into contemplation of these celestial mechanics, we begin to appreciate that Saturn's rings are not merely decorative accessories to a distant planet. They are active, evolving structures that embody fundamental principles of physics and astronomy. They demonstrate how gravity, electromagnetism, and orbital mechanics can create beauty from chaos, order from randomness, and temporary perfection from the raw materials of cosmic destruction. In their delicate balance between creation and decay, between order and entropy, Saturn's rings mirror the broader story of the universe itself, where beauty emerges from the dance of fundamental forces, persists for a while, and then gracefully fades back into the cosmic dark from which it came. We've journeyed through billions of years, from the first whispers of hydrogen gas to the grand spirals and elliptical cities of stars that populate our cosmos today. We've seen how Saturn's rings, those delicate bands of ice and rock, are themselves part of this greater story. Fragments that dance in gravitational resonances, shaped by the same forces that built galaxies from primordial darkness. But our story doesn't end with what we know. It reaches forward into questions still being asked and mysteries still unfolding. Even now, as you listen to these words, the Cassini spacecraft's data continues to reveal new secrets about Saturn's rings. Scientists have discovered that the rings are raining material down onto the planet's surface, a gentle shower of ice and organic compounds that may have implications for how life's building blocks are distributed throughout the solar system. This ring rain, as poetic as it sounds, is slowly eroding the rings themselves, reminding us that even the most beautiful structures in space are temporary. The James Webb Space Telescope, that magnificent time machine we've spoken of, is not just looking back at ancient galaxies. It's also turning its infrared eye toward our own solar system, studying the atmospheres of planets and moons with unprecedented detail. Soon, it may peer through Saturn's atmospheric haze and detect subtle changes in the ring system that ground-based telescopes simply cannot see. And what of the future explorers? NASA and other space agencies are already planning new missions to the outer solar system. Concept missions like the Enceladus Orbilander would visit Saturn's ice-covered moon, drilling through its frozen surface to sample the ocean beneath. Others propose sending swarms of tiny probes through the ring gaps, each one a messenger gathering data as it threads between the icy fragments. But perhaps the most intriguing possibility lies in what we might learn about ourselves. The same processes that shape Saturn's rings, gravitational resonances, collisional evolution, electromagnetic interactions, are at work throughout the universe. By understanding how particles organize themselves around Saturn, we gain insights into how planets form, how asteroid belts evolve, and how the cosmic web itself takes shape. The rings of Saturn are not just a local curiosity, they are a laboratory, a place where we can study the fundamental physics that governs everything from the smallest dust grain to the largest galactic supercluster. In their delicate beauty lies a deeper truth, that the universe is always building, always changing, always finding new ways to organize matter and energy into patterns of breathtaking complexity. As our knowledge grows, so too does our sense of wonder. Each answered question reveals 10 new mysteries. Each solved puzzle shows us how much more there is to explore. The rings of Saturn, for all their familiarity in photographs and documentaries, remain profoundly alien, a reminder that we live in a universe far stranger and more beautiful than our earthbound experience might suggest. And so, as Saturn continues its slow waltz around the sun, as its rings continue their ancient dance of creation and destruction, we continue to watch and wonder. From our small blue world, we send our instruments and our imagination across the solar system, gathering the whispers of distant worlds and weaving them into the ever-expanding story of cosmic discovery. The silent symphony of Saturn's rings plays on, a melody written in ice and gravity, conducted by the invisible hand of physics itself. We are privileged to listen, to learn, and to add our own small notes to the grand composition of understanding that connects us to the stars. In the end, perhaps that is the greatest gift of Saturn's rings, not just their beauty, but their invitation to dream, to explore, and to remember that we are part of something magnificent and mysterious, something that began in darkness and bloomed into light, something that continues to unfold with each passing moment as we drift together through the cosmic night. As Saturn's rings continue their ancient dance, performing their silent symphony across the cosmos, we arrive at one of the most captivating chapters in their story. The rings are not merely beautiful ornaments adorning the planet. They are active participants in a cosmic ballet, constantly evolving and responding to forces both seen and unseen. And perhaps nowhere is this more evident than in their relationship with Saturn's moons. Picture, if you will, a vast celestial orchestra where each moon plays its part in shaping the ring's intricate structure. These moons, ranging from tiny pebbles to massive worlds, act as cosmic shepherds, guiding and sculpting the ring material with their gravitational influence. Some moons orbit within the rings themselves, carving gaps and creating waves. Others patrol the outer edges, preventing particles from drifting too far into space. It's a delicate choreography that has been unfolding for millions, perhaps billions of years. The most famous of these gravitational partnerships is found in the Cassini division, that prominent gap between Saturn's A and B rings. For centuries, astronomers wondered what could create such a clear separation in the ring system. The answer came through careful observation and mathematical analysis. The gap is maintained by the moon Mimas, which orbits Saturn much farther out than the rings themselves. Particles in the Cassini division experience a gravitational tug from Mimas every time both the particles and the moon reach certain points in their orbits. This regular gravitational nudging gradually removes particles from the region, maintaining the gap like a cosmic street sweeper working on a schedule set by celestial mechanics. But Mimas is just one conductor in this grand orchestra. The moon Prometheus, barely 100 kilometers across, orbits just inside the narrow F ring. As it travels along its path, Prometheus gravitationally tugs at the ring particles, creating streamers and braids in the ring material. The effect is so dramatic that it can be seen changing from year to year, sometimes even from month to month. The F ring, already the most dynamic and chaotic of Saturn's rings, becomes even more turbulent under Prometheus's influence, developing kinks, clumps, and spiral structures that appear and disappear like cosmic weather patterns. Then there's Pandora, Prometheus's partner in this gravitational dance. Orbiting just outside the F ring, Pandora helps to confine the ring particles, preventing them from spreading outward into space. Together, Prometheus and Pandora act like cosmic shepherds, with Prometheus herding particles from the inside, while Pandora keeps them from straying too far on the outside. This shepherd-moon relationship is one of the most elegant examples of how gravity can create order from chaos, maintaining narrow rings that would otherwise disperse into space within a few million years. The intricate relationship between moons and rings becomes even more fascinating when we consider the embedded moonlets. These are tiny moons, some no larger than a few kilometers across, that orbit within the rings themselves. They're difficult to detect because they're so small and surrounded by countless ring particles, but their presence is revealed by the structures they create. As these moonlets orbit through the ring material, they create what astronomers call propeller features. These are dark and bright regions that extend outward from the moonlet's orbit, resembling the blades of an airplane propeller. The propeller features are created by the moonlet's gravity clearing a path through the ring particles, much like a boat creates a wake as it moves through water. The cleared region appears darker because it contains fewer particles to reflect sunlight, while the particles that are pushed to the sides create brighter regions. These propeller features can be tracked over time, allowing astronomers to study the orbital motion of the embedded moonlets and learn about the physical properties of the ring material. One of the most remarkable discoveries in recent years has been the detection of tiny moons being born within the rings themselves. The Cassini spacecraft observed several small objects in Saturn's A ring that appeared to be in the process of accreting from ring material. These proto-moons, if they survive the chaotic environment of the rings, could eventually become full-fledged shepherd moons, creating their own gaps and structures in the ring system. It's a beautiful example of how the rings are not just ancient relics, but active, evolving systems where new moons can be born and old structures can be reshaped. The gravitational influence of Saturn's moons extends far beyond simple shepherding. Some moons create spiral density waves that propagate through the rings like ripples on a pond. These waves are caused by the gravitational resonance between the moon's orbital period and the orbital periods of ring particles at specific distances from Saturn. When a moon and ring particles are in resonance, the moon's gravity gives the particles a regular, repeated push, causing them to bunch together and create a spiral wave that travels through the ring. These spiral density waves are not just beautiful structures, they're also incredibly useful scientific tools. By studying how the waves propagate through the rings, astronomers can measure the mass and thickness of the ring material, determine the size distribution of particles, and even detect variations in the ring structure that are too subtle to see directly. It's like using seismic waves to study the interior of a planet, except in this case the waves are gravitational and the planet is a disk of ice and rock orbiting Saturn. The relationship between Saturn's moons and rings also provides insights into the broader question of how planetary systems form and evolve. The process of moons shepherding ring particles and creating gaps in structures is not unique to Saturn. Similar processes occur around other planets with ring systems, and they may have played important roles in the formation of planetary systems around other stars. The gaps and structures we see in Saturn's rings today may be analogous to the gaps and structures that formed in the disk of material around the young sun, eventually leading to the formation of planets. Some of Saturn's moons have even more dramatic effects on the rings. The moon Enceladus, famous for its geysers of water vapor and ice particles, contributes material to Saturn's E-ring. The tiny ice particles ejected from Enceladus's south polar region are captured by Saturn's gravity and spread out to form a faint ring that extends far beyond the main ring system. This process demonstrates how moons can not only shape existing rings, but also create new ones, adding material to the system and extending its reach. The shepherding effect of moons is so important that it raises questions about the long-term stability of Saturn's rings. Without the gravitational influence of the moons, the rings would likely spread outward and dissipate into space within a few million years. The moons act like cosmic gardeners, constantly tending to the rings and maintaining their structure. But this raises an interesting paradox. If the moons are essential for maintaining the rings, and if some of these moons are themselves formed from ring material, then which came first? It's a chicken and egg problem that astronomers are still working to solve. The answer may lie in the dynamic nature of the Saturn system. Moons and rings may be constantly exchanging material, with moons occasionally being disrupted and adding their material to the rings, while ring material occasionally coalesces to form new moons. This ongoing cycle of destruction and creation could explain how the ring system has maintained its structure over geological timescales, despite the various processes that should cause it to dissipate. As we continue to study Saturn's rings and moons, we're discovering that their relationship is even more complex and beautiful than we initially imagined. The rings are not just passive collections of debris, but active, dynamic systems that respond to the gravitational influence of their moon shepherds. And the moons, in turn, are shaped by their interactions with the rings, creating a feedback loop that has been playing out for millions of years. It's a reminder that in the cosmos, nothing exists in isolation. Everything is connected, Everything influences everything else, and the result is a symphony of motion and structure that continues to reveal new secrets with each passing year. As Saturn's rings continue their ancient dance, we arrive at one of the most extraordinary discoveries in our cosmic neighborhood: the revelation that these rings are not silent at all, but rather sing with voices we're only now learning to hear. The story of how we discovered Saturn's symphony begins not with our eyes, but with our ears, or rather, with instruments sensitive enough to detect the electromagnetic whispers that flow like invisible rivers through the space around Saturn. It was the Cassini spacecraft, during its 13-year residence in the Saturnian system, that first taught us to listen to the rings. As the probe swept through Saturn's magnetosphere, its instruments detected something remarkable: radio waves, electromagnetic signals that seemed to pulse and vary with a rhythm all their own. These weren't random static or cosmic noise. They were structured, patterned, almost musical in their complexity. Scientists began to realize they were eavesdropping on conversations between Saturn's rings and its magnetic field, a cosmic dialogue that had been playing out for millions of years. The discovery began with what appeared to be radio emissions from Saturn itself, signals that waxed and waned in intensity as the planet rotated. But as Cassini's mission progressed and its instruments grew more sensitive to these electromagnetic phenomena, researchers noticed something curious. The radio signals weren't coming from Saturn's interior, as they had initially assumed. Instead, they seemed to originate from the space around the planet, from the very region where the rings cast their shadows and where charged particles danced in invisible spirals. What Cassini had stumbled upon was evidence of a phenomenon that scientists now call ring rain, a process by which the rings slowly shed material that spirals down into Saturn's atmosphere. But this wasn't just matter falling silently through space. As these tiny particles, many no larger than grains of sand, descended toward Saturn, they interacted with the planet's magnetic field, creating electrical currents that generated radio waves. The rings, it turned out, were singing as they slowly dissolved. But the music of Saturn's rings extends far beyond this gentle rain of particles. The gravitational interactions between the rings and Saturn's many moons create what scientists describe as resonances, points where the orbital periods of ring particles and moons align in precise mathematical relationships. These resonances act like tuning forks in space, creating waves that ripple through the ring system, sculpting gaps, maintaining boundaries, and generating patterns that pulse with their own distinct frequencies. Consider the Cassini division, that prominent gap in Saturn's rings that's visible even through modest telescopes from Earth. This gap exists because of a gravitational resonance with Mimas, one of Saturn's inner moons. Ring particles that would otherwise orbit in this region are swept away by Mimas's repeated gravitational tugs, creating a zone of relative emptiness. But this isn't a static void. It's a dynamic space where gravitational forces create standing waves, invisible oscillations that maintain the gap's sharp edges and contribute to the overall harmonic structure of the ring system. Even more intriguing are the spiral density waves that propagate through the rings like ripples on a cosmic pond. These waves are generated when the gravitational influence of Saturn's moons creates disturbances that travel outward through the ring material. As these waves move, they compress and rarefy the ring particles, creating alternating regions of higher and lower density that spiral outward from their points of origin. From Cassini's perspective, these waves appeared as subtle variations in the ring's brightness and opacity, but they represent something far more profound: the rings responding to gravitational music, dancing to rhythms set by the orbital motions of distant moons. The electromagnetic symphony of Saturn's rings is perhaps most dramatic during what scientists call radio storms. These occur when charged particles from Saturn's magnetosphere interact with the ring material, creating bursts of radio emission that can be detected across a wide range of frequencies. During these events, the rings essentially become vast radio antennas, broadcasting their presence across the solar system. The intensity and frequency of these emissions provide clues about the density and composition of different ring regions, allowing scientists to map the ring's structure using radio telescopes rather than optical observations. One of the most haunting aspects of Saturn's ring music is how it changes with the planet's seasons. Saturn's axial tilt means that different parts of the ring system receive varying amounts of sunlight throughout the planet's 29-year orbital period. As the rings warm and cool, their material expands and contracts, subtly altering the spacing between particles and the resonant frequencies of the system. The rings literally change their tune as Saturn moves through its long year, playing summer songs and winter melodies that unfold over decades. The spokes that occasionally appear in Saturn's B ring add another layer to this cosmic composition. These radial features, which can span thousands of kilometers, are thought to be caused by electromagnetic forces that temporarily lift tiny particles above the ring plane. As these particles rise and fall, they create transient patterns that rotate with the rings, like ghostly fingers reaching across the ring system. The formation and dissolution of these spokes generates its own electromagnetic signature, adding percussive elements to the ring's ongoing symphony. Perhaps most remarkably, recent analysis of Cassini data has revealed that the rings themselves may be influencing Saturn's rotation period. The planet's radio emissions, which scientists use as a proxy for its rotation rate, appear to vary in ways that correlate with changes in the ring system. This suggests that the rings and the planet are engaged in a kind of electromagnetic feedback loop, with each component influencing the other's behavior in ways that are still being decoded. The music of Saturn's rings operates across timescales that dwarf human experience. Some of the wave patterns in the rings have periods measured in hours or days, while others unfold over years or centuries. The great resonances that shape the ring system play out their gravitational melodies over millions of years, creating harmonies that began long before Earth had oceans and will continue long after our sun begins to fade. As we listen to Saturn's rings through our increasingly sophisticated instruments, we're not just detecting electromagnetic noise or gravitational disturbances. We're hearing the voice of a complex, dynamic system that has been composing itself for millions of years. Each radio wave, each resonance, each gravitational ripple is a note in a symphony that encompasses the entire Saturnian system, a composition written in the language of physics, but possessing a beauty that transcends mere science. The rings of Saturn remind us that the universe is full of music, playing on frequencies and timescales that we're only beginning to appreciate. In learning to hear their silent symphony, we've discovered that even the most serene and seemingly static features of our cosmic neighborhood are alive with motion, interaction, and change. The rings sing not because they choose to, but because they must. Because the fundamental forces that govern their existence naturally create patterns, rhythms, and harmonies that speak to something deep within us that recognizes music wherever it may be found. As we listen to Saturn's rings singing their electromagnetic songs across the cosmos, we find ourselves drawn to the subtle harmonies that govern not just this distant world, but the very nature of music itself. For Saturn's rings, in their orbital precision and gravitational resonances, are teaching us something profound about the mathematical foundations that underlie all melody, rhythm, and harmony. When Cassini first detected radio emissions from Saturn's rings, scientists realized they were hearing something extraordinary. These weren't random electrical discharges, but structured patterns, frequencies that rose and fell with the orbital mechanics of countless ice particles. Each ring system produces its own signature, its own voice in the cosmic choir. The A ring hums at one frequency, the B ring at another, while the gaps between them create intervals of relative silence, like the spaces between musical notes that give melody its shape. This discovery has opened our ears to a deeper truth. The same mathematical relationships that govern Saturn's rings also govern the music we create here on Earth. When two frequencies align in simple ratios, 2 to 1, 3 to 2, 4 to 3, they produce the consonant intervals we recognize as octaves, fifths, and fourths. Saturn's rings, locked in gravitational resonances with its moons, naturally fall into these same mathematical relationships. The Cassini division exists because particles there would orbit twice for every orbit of the moon Mimas, creating a 2 to 1 resonance that clears the gap. It's the cosmic equivalent of an octave, a doubling of frequency that our ears recognize as the same note in a higher register. But Saturn's musical lessons go beyond simple harmony. The rings also teach us about rhythm, about the pulse that drives all music forward. As ring particles orbit Saturn, they create density waves, compressions, and rarefactions that ripple outward like sound waves through air. These waves have their own periodicities, their own beats, some taking hours to complete a cycle, others mere minutes. If we could speed up these rhythms, compress millions of years of ring evolution into moments, we would hear the steady pulse of cosmic percussion, the drumbeat of gravity itself. The electromagnetic emissions from Saturn's rings follow these same rhythmic patterns. When solar wind particles strike the rings, they generate radio waves that pulse with the planet's rotation, creating a natural metronome that has been keeping time for billions of years. This is rhythm in its purest form, unmarked by human intention or emotion, yet following the same mathematical principles that make a drummer's beat compelling to our ears. Even more fascinating is how Saturn's rings demonstrate the principle of resonance that makes music possible. When you pluck a guitar string, it doesn't just vibrate at one frequency. It vibrates at multiple frequencies simultaneously, producing what musicians call overtones or harmonics. These additional frequencies occur at simple mathematical ratios to the fundamental frequency, creating the rich, complex sound that distinguishes a guitar from a piano or human voice. Saturn's rings work the same way. The fundamental orbital frequency of ring particles creates a bass note, but gravitational interactions with Saturn's moons generate harmonics, additional frequencies that enrich the overall sound. When the Voyager spacecraft first recorded these emissions and converted them to audio, scientists were struck by how musical they sounded, how naturally they seemed to follow the patterns our ears expect from earthly music. This shouldn't surprise us, really. Both music and planetary mechanics are expressions of the same underlying mathematical order. The ancient Greeks understood this connection, developing theories of cosmic harmony that linked the movements of celestial bodies to musical intervals. They believed the planets themselves sang as they orbited, creating what they called the music of the spheres. While we now know planets don't produce audible sound in the vacuum of space, Saturn's rings have shown us that the Greeks were onto something profound. The cosmos does make music, just not in the way they imagined. Modern composers have begun incorporating these cosmic rhythms into their work, using the actual frequencies detected from Saturn's rings as the basis for new compositions. The result is music that feels both alien and familiar, following patterns our brains recognize as musical while drawing from sources no human has ever heard directly. It's as if Saturn itself has become a collaborator, offering melodies and rhythms from the deep space laboratory of its ring system. But perhaps the most beautiful aspect of Saturn's musical nature is how it reveals the continuity between the cosmic and the intimate. The same mathematical relationships that keep Saturn's rings stable and singing also govern the way our ears process sound, the way our brains recognize melody, and the way our hearts respond to rhythm. When we listen to music, we're participating in patterns that extend far beyond our earthly experience, patterns that resonate through the solar system and beyond. The rings of Saturn are still singing, still teaching us about the deep connections between mathematics, music, and the cosmos. Every time we hear a perfect fifth or feel the pull of a steady beat, we're experiencing echoes of the same forces that have been shaping Saturn's rings for billions of years. In this way, Saturn's silent symphony becomes not just a distant curiosity, but a bridge between the grandest scales of cosmic architecture and the most personal moments of human experience, when music moves us in ways we can't quite explain, but somehow always understand. As Saturn's influence reaches every corner of its domain, we find ourselves at the threshold of understanding something profound about our place in the cosmic order. The rings of Saturn, for all their beauty and complexity, are ultimately a mirror reflecting our own journey through space and time. Throughout our exploration, we've witnessed how these delicate bands of ice and rock emerge from chaos, organize themselves into intricate patterns, and dance to the gravitational music of their celestial companions. We've seen how they respond to the subtle nudges of shepherd moons, how they repair themselves after collisions, and how they sing their electromagnetic songs into the void. In their ephemeral existence, lasting mere hundreds of millions of years in a universe billions of years old, Saturn's rings remind us that even the most magnificent structures are temporary, beautiful precisely because they will not last forever. But perhaps the most remarkable revelation is how these rings serve as a bridge between the vastness of space and the intimacy of human understanding. Every mathematical equation that describes their motion, every gravitational resonance that shapes their gaps, speaks to fundamental principles that govern not just Saturn's domain, but the entire cosmos. The same forces that create the Cassini division also sculpt galaxies. The same electromagnetic fields that generate spokes in Saturn's rings also power the aurora dancing above our own planet's poles. As we've journeyed from the earliest telescopic glimpses of Galileo to the final photographs of the Cassini spacecraft, we've traced not just the story of Saturn's rings, but the story of human curiosity itself. Each generation of scientists has built upon the discoveries of the last, adding new instruments, new theories, and new questions to our understanding. The rings that once appeared as mysterious handles through Galileo's primitive telescope have revealed themselves to be one of the most sophisticated and dynamic systems in our solar system, a natural laboratory where the laws of physics play out on a scale both magnificent and comprehensible. In the end, Saturn's silent symphony continues to play, its gravitational notes resonating through space, whether we listen or not. The rings will continue their ancient dance, shepherded by their moons, carved by their resonances, and slowly but inexorably spiraling inward toward their eventual dissolution. Future generations may witness transformations we can only imagine, perhaps even the birth of new rings from the destruction of wayward moons, or the gradual fading of the current system into scattered debris. Yet in this cosmic perspective, our brief moment of observation becomes all the more precious. We are the conscious witnesses to this celestial performance, the ones who can decode its rhythms and translate its beauty into human understanding. Through our study of Saturn's rings, we participate in the universe's own process of self-discovery, adding our small but significant voice to the eternal conversation between matter and meaning, between the dance of particles and the poetry of human comprehension. Tonight, as you drift towards sleep, remember that somewhere in the darkness above, Saturn continues its stately progression around the sun, its rings catching and scattering sunlight in patterns of breathtaking complexity. Those rings carry within them the memory of ancient collisions, the whispers of gravitational forces, and the promise of continued wonder for all who dare to look up and ask the simple but profound question: what is that beautiful thing in the sky? In seeking to answer that question, we discover not just the secrets of Saturn's rings, but something essential about the curious, pattern-seeking, beauty-loving creatures we are. forever reaching toward the stars with instruments of glass and metal, mathematics and imagination, in our endless quest to understand our place in the cosmic symphony. So here we stand at the edge of everything, peering through the cosmic veil at Saturn's most magnificent secret. For the past 11 chapters, we've journeyed through the delicate dance of ice and rock, witnessed the invisible forces that sculpt perfection from chaos, and listened to the electromagnetic whispers of a world singing to itself across the void. We've traced the formation of gaps that exist because of moons that aren't there, watched shepherd satellites tend their flocks of particles, and marveled at the intricate mathematics that govern every graceful curve and spiral density wave. The rings of Saturn are not merely beautiful ornaments adorning a distant world. They are libraries written in ice, textbooks of celestial mechanics played out on a stage so vast that entire moons could pass through their gaps without touching the edges. They are laboratories where the fundamental forces of nature conduct experiments in real time, where gravity and electromagnetism collaborate to create structures of breathtaking complexity from the simplest ingredients imaginable. We've discovered that these rings are paradoxically ancient and young, formed perhaps from the destruction of an ancient moon, yet constantly renewed by the very forces that shape them. They are ephemeral on cosmic timescales, raining down onto Saturn's atmosphere even as we speak, yet they have persisted long enough for us to witness their majesty and decode their secrets. In perhaps 100 million years, they will be gone, leaving behind only the memories encoded in scientific papers and the faint traces of their material absorbed into Saturn's clouds. But their story extends far beyond their own existence. The rings serve as a natural laboratory for understanding planetary formation, the dynamics of disk systems, and the delicate balance between creation and destruction that governs all celestial bodies. The same processes that maintain Saturn's rings also operate in the accretion disks around young stars where planets are born, in the asteroid belts of distant solar systems, and in the vast spiral arms of galaxies themselves. Through the patient observations of ground-based telescopes, the flyby missions of Pioneer and Voyager, and the dedicated service of Cassini, we have learned that Saturn's rings are a symphony of resonances, a carefully tuned instrument where every particle knows its place and every gap tells a story. The spokes that appear and disappear with the rhythm of Saturn's magnetic field, the propeller features carved by embedded moonlets, the braided strands of the F-rings shepherded by Prometheus and Pandora. All these phenomena speak to the exquisite sensitivity of gravitational and electromagnetic systems. We have seen how the rings respond to seasons, growing brighter and dimmer as Saturn's orientation changes relative to the Sun, how they interact with the planet's magnetosphere to create aurora and radio emissions, and how they serve as both source and sink for the tiny particles that populate the space around Saturn. They are not static structures, but dynamic, living systems that breathe with the rhythm of orbital mechanics. The mathematical beauty underlying these structures reveals itself in the Kirkwood gaps, carved by resonances with moons, in the spiral density waves that propagate through the ring material like ripples in a cosmic pond, and in the delicate balance between the forces that would tear the rings apart and those that hold them together. Each particle in the rings follows the same fundamental laws that govern the motion of planets, yet collectively they create patterns of stunning complexity and beauty. Perhaps most remarkably, we have learned to listen to the rings themselves. The electromagnetic emissions generated by their interaction with charged particles and magnetic fields create a kind of music, a soundtrack to the cosmic dance that plays out in frequencies beyond human hearing, but well within the range of our instruments. These signals carry information about the composition, structure, and dynamics of the rings, allowing us to probe their secrets even when we cannot see them directly. The rings also serve as a mirror, reflecting our own place in the cosmic order. We are made of the same elements that comprise these distant structures, forged in the cores of ancient stars and distributed through space by supernovae and stellar winds. The silicon in the rocky components of ring particles, the oxygen in their ice, the iron in their dust. All these elements flow through our own bodies. We are connected to Saturn's rings, not merely as observers, but as participants in the same cosmic story. As we contemplate the future of the rings, slowly spiraling inward towards Saturn's atmosphere, we are reminded of the impermanence that characterizes all cosmic structures. Stars are born and die. Galaxies collide and merge, and even the most stable planetary systems eventually succumb to the passage of time. Yet this impermanence does not diminish their beauty or significance. If anything, it enhances both, reminding us that we are privileged to witness these phenomena during the brief cosmic moment when they exist. The story of Saturn's rings is ultimately a story about the power of scientific inquiry to reveal hidden beauty and meaning in the universe. What appeared to early astronomers as simple appendages to a distant planet have revealed themselves to be among the most complex and beautiful structures in the solar system. They challenge our understanding, inspire our imagination, and reward our patience with discoveries that reshape our view of how worlds are built and maintained. As future missions venture forth to explore other ringed worlds, from the ice giants, Uranus and Neptune, to the distant ring systems that may surround exoplanets in other solar systems, they will carry with them the lessons learned from Saturn's magnificent example. The techniques developed to study these rings, the theoretical frameworks constructed to understand their behavior, and the sense of wonder they inspire will guide our exploration of cosmic structures yet unknown. And so we conclude our journey through Saturn's silent symphony, this cosmic composition written in ice and stone, conducted by gravity and electromagnetism, and performed on a stage of unimaginable grandeur. The rings will continue their ancient dance long after our own brief moment of observation has passed, but through science we have learned to hear their music and appreciate their beauty. In studying them, we have not only expanded our knowledge of the cosmos, but also deepened our appreciation for the intricate, interconnected nature of all things. The rings of Saturn remind us that even in the cold depths of space, beauty and order can emerge from chaos, that simple physical laws can create structures of breathtaking complexity, and that the universe is far more wonderful and surprising than we ever dared imagine. As we drift off to sleep beneath our own small portion of the cosmic sky, we can take comfort knowing that somewhere out there, Saturn's rings continue their eternal dance, singing their silent symphony to anyone wise enough to listen. In the end, perhaps that is the greatest gift of Saturn's rings, not just the knowledge they provide about planetary formation and celestial mechanics, but the reminder they offer that we live in a universe of profound beauty and mystery, where even the most distant and seemingly alien structures can speak to something deep within the human spirit. They are a testament to the power of curiosity, the value of patient observation, and the eternal human desire to understand our place in the vast cosmic symphony of which we are all a part. Sleep well, fellow traveler, knowing that while you rest, the rings of Saturn continue their graceful dance, and the universe continues to sing its ancient songs to those who take the time to listen.